Today we will be using similar triangles to find slope. Slope is a fancy word for rate of change or constant of proportionality. Constant proportionality is specifically rate of change when the relationship is proportional or it goes through 0, 0. Okay, rate of change and slope are used interchangeably for proportional or non-proportional relationships. Okay, so we are going to be using slope from here on out. Okay, now we are going to be using similar triangles. Okay, similar triangles mean the ratio of the legs can be simplified to be the same thing. Okay, congruent would mean they're exactly the same. Okay, so similar is they simplify to the same, the ratio of the vertical height to the horizontal height. Okay, we'll make a similar triangle. All right, so let's take a look at number 1 here. It says the graph of line W, which you can see is labeled here as this diagonal line. The graph of line W is shown. Use the similar slope triangles to compare the slopes of segment AB to BD. So we are comparing this segment here to this segment here. And we are going to use our triangles in order to help us do that. And again, the vertical height over the horizontal height. Okay, so my vertical height here on AB, on segment AB, is 1, 2, 3, 4, 5, 6. Okay, so vertical height is 6 and horizontal height is 1, 2. Okay, which simplifies to 3 or 3 over 1. Okay, now let's take a look at BD. Okay, that's this one here. So we're going to look at the vertical height between B and E, 1, 2, and 3, over the horizontal height, 1, 3 over 1, which also simplifies to 1. So you can see they are similar triangles because they both simplify to the same rate. This is the slope of the line. Okay, and you can recognize they're both the same, which shows the slope of this line is 3. Okay, again, vertical height over horizontal. Okay, they also call this rise over run. So rise is your vertical height, run is your horizontal height. Okay, slope equals rise over run. So in this case was 6 over 2, 3 over 1, which makes that slope 3. Okay, let's take a look here at the second one. Okay, now our vertical height here, notice we are going downhill here. So we are actually going down 1, 2, 3, 4, 5, 6, 7, 8. So we are negative 8. That means our slope is going to be negative here because we are going downhill from left to right. Okay, and my horizontal height is 2, so negative 8 over 2, which simplifies to negative 4 over 1, or negative 4. Okay, so the slope between GI is negative 4. Slope here on IK is going to be 1, 2, 3, 4 over 1 between JI, and again, negative. So that simplifies to the same exact thing. Okay, so my slope is negative 4. Let's do one more here. Notice this line is a little bit flatter than the two we've looked at prior. Okay, so this one we're going to look at our vertical height again. So this one we're comparing the slopes BC to CE. All right, so BC to CE. Okay, let's take a look at this one first. My vertical height is 2, and my horizontal 1, 2, 3, 2/3. Okay, and that is fully simplified. Again, this is positive. It's going up from left to right. Okay, so let's take a look here between E and D, 1, 2, 3, And 4 is my vertical over 1, 2, 3, 4, 5, and 6 is my horizontal. This also simplifies to 2/3. Okay, so the slope for this one is going to be 2/3. It is okay to have a fraction as your slope. Okay, that just means it's a little flatter. Okay, and there is one more that you can try here and a couple more if you'd like to try those. Okay.